everyone, and thank you for joining us today. My name is Danielle Fisher, and I'm the event manager here at Eco Canada. And today's session is called Introduction to National Energy Codes of Canada for Buildings 2020. Before we start, I would like to take a moment to recognize the traditional Indigenous lands where Eco Canada's office is based in Calgary. At Eco Canada, we're committed to working towards respectful acknowledgement, collaboration, and reconciliation with Indigenous peoples across Canada. This starts with acknowledging our honor and privilege to live and work within the Treaty 7 territory. Today, we are presenting from the City of Calgary, home to the Métis Nation of Alberta, Districts 5 and 6. We would also like to take this time to acknowledge traditional territories and oral practices of the NECB, home of the Blackfoot Confederacy, which includes the Siksika, the Piikani, and the Kainai First Nations, and the Tsuut'ina and Goodstoney, which include the Chiniki, Bearspaw, and Wesley First Nations. Before we start, there are a few housekeeping guidelines for today's session to ensure that everyone can enjoy and participate in the session effectively. All participants are muted, so please check your audio settings to ensure that you can hear us properly. If you're experiencing any technical issues, please use the question box and select Eco Canada, the organizer, and I will do all that I can to resolve the issue. Today's webinar is being recorded and will be made available on demand to you within the next 24 hours. Everyone who registered for the webinar will receive an email with a link to the video. Any questions that you have about the webinar or today's topic can be submitted through the chat box or question box. We will have dedicated time at the end of the webinar to answer any questions from the audience. Finally, we really want to know what you think about our webinars and how we can keep improving. You'll be sent a short survey after the webinar ends. Please let us know what you think or if you have any comments or suggestions about the webinar. This is also a time for everyone to put where they're coming from and what they're hoping to get out of this webinar, and as an opportunity in the chat in the bottom of the screen. We'd love to hear where you guys are coming from. Eco Canada's vision is to build the world's leading environmental workforce. Eco Canada seeks to help environmental workers succeed at each step of their career journey. To do this, Eco Canada has developed programs tailored to individuals at different stages of their career. For those looking to enter the environmental workforce, Eco Canada provides training through the BEAR program and accreditation for environmental programs at post-secondary institutions. Eco Canada also provides opportunities for new workers to break into the environmental sector through wage funding for co-op students and recent post-secondary graduates. For those already employed as environmental workers, Eco Canada provides the Environmental Professionals EP and Environmental Professionals in Training EPT certifications and EPT students. Lastly, Eco Canada provides opportunities for those with vast experience as environmental workers to provide guidance and direction to Eco Canada's products and programs through advisory committees and emeritus memberships. Now I'd like to introduce you to our speaker. Joining us is Kim Walton. Kim is a designer and principal at Bocro Designs, and for the last 40+ years, Bocro Design has been in the business of designing energy-efficient homes and small buildings from the Alberta foothills. Using their skill in energy modeling and employing excellence in building science, they design and manage passive house, deep energy retrofit, and net zero projects across Canada. Bocro is a Métis-owned business, and they have certifications as passive house designers and builders, as well as energy and net zero building advisors. So we'd love to hear where you guys are coming from. So please leave that in the chat and maybe what you guys are hoping to look for in getting out of this webinar. Over to you, Kim.
Okay, thank you, Danielle. My name is Kim. Next slide. And I think I'm Danielle. I'm speaking to you from the Bearberry Valley, which is the traditional hunting ground of the Blackfoot and Métis Nation in Alberta. Next slide. I've been, as Danielle had said in the bio, I've been working on sustainable buildings for a very long time, since the early 80s. And this is a picture of me. It looks like I'm about 12, which I'm a little bit older than that. There's some certifications in terms of building envelope and uh, energy efficiency and building science. And I'm associated with these organizations: Passive House Canada, Passive House Alberta, and Passive Alberta. Next. The purpose of this NECB, which is the National Energy Code for Buildings in Canada, benefit Indigenous associations and communities and infrastructure projects. Next slide. So I'm going to do a real quick overall idea of how really well-designed buildings work. So we work on thinking about buildings as a system, and we have 5 elements that we consider in terms of making a building better. Next slide. First in line here is insulation. So it's just like putting a jacket, a scarf, mittens, a hoodie on for cold weather, but the same applies for hot weather. Next slide. The idea is that the building is airtight, just like if you're putting on a jacket and you do up the zipper, you're much warmer than you are with the zipper open. Next slide. We work on thermal bridge-free construction, and what that means is that warm parts of the building are not sticking through to the outside of the building. And this is a thermograph image at the very bottom of the same building. Before and after a retrofit, where at the beginning there was a lot of thermal bridging, and in the end, a lot less. Next slide. And we work on windows and doors being very good and appropriate for the climate that they're in. Next slide. And we make sure that this airtight building has some active ventilation so that it provides fresh air for the inhabitants and a comfort level that is extremely healthy. Next slide. So all of these things work together to make a more comfortable building. These images, which are drawn by somebody more clever than me, just indicate a history of buildings. And so in the first image, we have a building, a structure that is oriented correctly, takes advantage of the sun, right-sized, doesn't require a lot of energy to keep it warm when it's cold. And as human beings progress, they start to enclose buildings. And once they enclose them, they require an even bigger fire in order to keep themselves warm, because they haven't thought out the environmental aspects of the building. And that progress to the building and the building envelope being ignored completely, and just keep adding more and more complex systems to keep people kind of comfortable. And in the end, what the idea about creating buildings that require less energy and less inputs, and are also, again, thinking about their environment and how they're situated in the world and on the planet, and where they are on the planet, and requiring very little inputs in order to keep the inhabitants comfortable. Next slide. So we're going to start with an introduction. This is the part of the presentation today that we're going to get progressively more technical. And I'm probably going to race through it quite quickly in order to be able to have some discussion at the end. Next slide. So the NECB is actually something that happens underneath the National Building Code of Canada, or the National Building Code of Canada is the NECB is part of the National Building Code of Canada. For those of you that don't know what that is, next slide. It's a document that is developed by Natural Resources Canada, but it is developed by people who actually know about buildings. It's not just a government or government employee issue document. It's developed through consultations across Canada for the best way to do things, the best way to accomplish what is required in order to meet the stated goals, the objectives of safety, health, accessibility, fire, and structural protection of buildings and the environment. Next slide. So these are some of the standing committees that I think I've got the most of them here that have input from about 280 volunteers from across Canada that create the document and changes to the document for every issue of the National Building Code of Canada. Next slide. So the first building code was developed between 1939 and 1945, and it was including not very many different aspects of building, but it was needed, and it was developed alongside international building codes at the time, just understanding that there needed to be a basis for building around the world. And so now the most current document, there's one that's been issued in 2023, and that one is about 1,570 pages, so grown quite a bit, and 2 volumes, and has 8 parts with the first volume and 2 parts, and part 9 has, or sorry, volume 2 has a couple of parts, and then there's some appendices and indexes that are part of the whole building code document. It is not a simple document to go through. Next slide. But it forms the basis of most building design in the country. And the idea is that we would have a building code that's consistent across the country. Each province is required to adopt the current building code in Canada, and they are allowed to take that model code, and they are able to, as a province, add to it and create their own building code, which is at the very least the same as the model building code, but must be more stringent in any additions. Next slide. One thing I forgot to mention, and I think I had brought that to attention in one of the slides earlier, the National Building Code of Canada and also the NECB are minimum codes. In other words, you can't build to a lesser quality than what's described in the National Building Code or the National Energy Code for buildings. The next slide, please. So now we're going to talk about the history of the National Energy Code. So it is not new, although a lot of people don't know much about it, but it's been developed since the 1970s, back when we thought we were going to run out of oil. Not that we were using too much oil, but that we were going to run out of oil. Next slide, please. The uptake of the energy codes was not really wanted or accepted by industry, and it had a lot of hiccups. And so the basis of the existing National Energy Code for Buildings was established in 1997. So that's a few years ago. Next slide, please. The 2011 Model National Energy Code for Buildings was renamed and shortened to the National Energy Code for Buildings for consistency with other model national energy codes. The 2011 code was intended to be 25% better than the code before it, but it was still not enforced. It was offered as something that could be used as a model. Next slide, please. So in 2015, there were new changes, 90 new changes, and the idea of the 2015 NECB was that the efficiency measures that are explained and laid out in the 2015 code are 10 and 14% more efficient, and that the idea is that this would help to reduce energy consumption and save on energy bills and reduce peak energy demand, which many people have heard about. Peak energy demand is the thing we fear the most for electrification. The idea is that we want to be sure that buildings are not the source of energy failures in our provinces and in our country. The most cost-effective time to incorporate these energy efficient measures, of course, is when you're building a building, not later. So this is particularly true in terms of the building envelope. So once you put a building up, it's pretty unlikely that you're going to make any significant changes over many years, decades likely. Next slide, please. So the NECB, what is it exactly? Next slide, please. So it focuses on 5 components: the building envelope, lighting, heating, ventilation, and air conditioning systems, service water heating, and electrical power systems and motors. Next slide, please. The 2020 edition has an addition to the Energy Code that is something that is new-ish. The province of BC has certainly been working on this for the last 10 or 15 years, but the new code is establishing tiers that will be developed over time. So Tier 1 is where the National Building Code or the National Energy Code is at this moment, but the next version will be at Tier 2, 25% over more efficient over the target of Tier 1, and Tier 3 will be 50% over the baseline target, and Tier 4 will be a 60% improvement over the baseline target. Next slide, please. So there are the ways that you show that you're in compliance to the jurisdiction when you're doing a building permit or when you're designing a building are in 3 ways. So the compliance comes in either prescriptive, a trade-off, or performance. And proof of these are required for building permits across Canada. Next slide, please. So in terms of code harmonization, the adoption of the National Building Code and the National Energy Code for buildings is important. That it's important that all provinces are adopting these codes and enforcing the codes in order to ensure that there are no particular benefits to buildings worse in any particular location in Canada. And it's about making sure that there is that prevents inconsistent model code adaptations, which can lead to barriers to trade and investment in labor mobility within Canada. So that's why the harmonization of the codes across Canada is important, and the consistency. Next slide, please. So I'm going to start on some slides here. Thank you to Codes Canada for issuing these slides, and you can access more information, more in-depth information from Codes Canada and from the province of Alberta, which has many of the slides in a slide deck on their website. Next slide, please. So building envelope, remember we early on talked about thermal bridge modeling, thinking about the transfer of heat and air leakage from the building to the outside. So next slide. That's the way that we do this is we're thinking of the means of collection of the components in the separate conditioned space from the unconditioned space and the exterior air in the ground, and separating those spaces and ensuring that the condition temperatures are not differing more than 10 degrees Celsius at design conditions. Next slide, please. That building, by the way, is a pretty poor example of a good building envelope. The compliance options are prescriptive. options, a prescriptive path, which is usually a checklist. Well, it is a checklist that where you're just making sure that your building is complying to the things on the list. Sometimes that's not good enough, or that's something you want to try something new, or you have equipment that that is predetermined. You use a trade-off path in that case, and there are tools provided by NRCan for the calculations for the trade-off path. And then the last way is a performance path, whole building modeling, where you think about the whole building as a whole. And that requires energy modeling, and that is where you can tweak the performance of the building so that it meets the requirements of the NECB through unique building structures, unique equipment, and unique building methods. Next slide, please. So one big deal in terms of building envelope is the continuity of insulation. It's not just insulation, but making sure that insulation is continuous. And in this slide, what's showing here is that in the first slide, there's continuity of insulation, where insulation is continuously in the same location and is protecting the building, the outside of the building, from environmental forces. And in the second example, which might seem like it's the same thing, it is not, because there's this disconnect between the insulation and the ground and the outside. So there's some protection, but there's also heat being lost to the ground in this case, and through the stem wall and the footing. Next slide, please. Air leakage is a super important part of what the code enforces, and there's a minimum air leakage requirement for buildings under the code. And this is an example with curtain walls. So the testing for windows is important, and the amount of leakage through windows. It's also important to ensure that the entire building and the building envelope is of a certain air tightness. Next slide, please. Something that's used often in the building code is something that's called a U value, which is pretty confusing. So we all really know what an R value is. RSI is the metric version of R, and you can get a U value in imperial, or you can get a U value in metric. But if we know the RSI of a product, we can get the U value by dividing 1 by the RSI value. Next slide, please. So that's only so that you can have a look at this chart and say, what the heck is this? So what is a U value and what is watts per meter squared Kelvin? Like, we don't really know. You don't have to know. You can do a little bit of math to figure this out, I guess. But what we have here laid out for many components of the building is what's required from zone to zone in Canada. And next slide, please. And for where I am right now, that's in 7A, and that's most of Canada. Some parts of Canada are in zone 4, not very much, but there's a lot of people living there. Zone 5 and 6 for some of the southern parts of Canada, but most of Canada is zone 7A, 7B, and zone 8. Next slide, please. So the degree days is another term that's used, and that means that these are the number of heating days that are requiring heating. That is used universally as something that identifies what kind of a zone the building is in. Next, this is about fenestration. By the way, fenestration is another fancy word for glass or windows. So in this case, there is, in the National Energy Code, there is a requirement to have less windows in a more cold environment. So the degree days is at the bottom, heating degree days is at the bottom, and then the number of windows that are allowed in the building itself, or as a percentage, is lessened as we're getting into colder climates, according to the Energy Code. Next slide, please. So this is a map of Canada, and you can see the lines of 7,000, 6,000, and 5,000 heating degree days. And in this case, it's showing the percentage of window and door to wall ratios, which is higher for milder climates and less for more severe climates. Next slide, please. So the lighting portion of the NECB is the next thing that we're going to look at. Next slide, please. So the interior lighting is calculated, and there are two methods for figuring that out. Next slide, please. And that's either by the building area or space by space. And when somebody's considering how you meet the code requirements, this will make more sense. Sometimes space by space will make more sense in targeting lighting levels, but by building area may actually, for a larger building, make more sense. Next slide, please. There are lighting tables and there are tools for figuring all of this out. Next slide, please. The scope for electrical systems isn't just about lighting. It's about all of the mechanical systems that are in a building, including the thermostats, including the pumps, the heat pumps, the blowers. All of the equipment is calculated within the electrical energy that's used in the building. Next slide, please. And so this list, there's a list of some of the things that you would be looking for equipment minimum performance that needs to comply with the building, with the energy code. Next slide, please. And I put this slide in because it's fun. It's also important. Ducts, which are not DUCK, but the DUCT, they need to be sealed. And that's something that they need to be sealed well, so that they're delivering the hot or cold air that the equipment is designed to deliver to the places it's designed to deliver, and not to places that are hidden or where the ducts are. So it's an important part of and much ignored part of the energy code. Next slide, please. So with the trade-off concept, it still is considering energy that used throughout the system, and the tools that are used for the trade-off concept do include those considerations. Next slide, please. So the system efficiency approach considers the HVAC system as a whole and is intended to permit flexibility for typical designs. So it will compare the total reference system. And in the code, a reference building is a building that's built to the previous code or code built. And what the efficiency needs to do is be back to that list, the tiered code, 25%, 50%, 60% better than the reference system. Next slide, please. So we're limited in the energy sources that can be used in the energy code. Diesel is not included. The backup equipment has to meet the prescriptive requirements. So you can't just have some small or undersized equipment that's backed up with something that is bigger and less efficient. Next slide, please. The equipment performance efficiency will comply with the energy efficiency regulations, and the backup equipment must comply with the prescriptive path. So the prescriptive path is one of the ways of checking for the efficiency of the building, and you can also use the performance path as well. Next slide, please. So this is a national energy code for hot water systems. Next slide, please. So again, this is about the proposed efficiency is better than the reference. And that is consistent through the entire code. These are some of the things that we would be looking for in terms of hot water efficiency. Next slide, please. And in the trade-off, sometimes a more efficient equipment can be used as a trade-off for less efficient equipment, and you are obliged to use the tools in order to figure that out. Next slide, please. For power systems, next slide, please. So the electrical power systems that are outside are also considered as part of the whole building. Next slide, please. And for the power systems, you're not allowed to use trade-offs, the trade-offs tools. It's just either the prescriptive path or the performance compliance. Next slide, please. And there are referenced standards for equipment. So these are motors and blowers that we see in this picture. Next slide, please. Part 8 of the NECB, next slide, please, is an outline for the building performance path. It is the part that you use of the code, of the National Energy Code, to consider to come up with ways of using a building performance overall, looking at the building as a whole, in lieu of trade-off or performance paths. So that's a whole building energy use comparison. Next slide, please. This is the process by which you would go about using Part 8. And the preliminary modeling and path selection and you consult the code also means that you're doing some optimization work before design is completed. Next slide, please. So just as an overview of what's required in the NECB, to insulate thermally active opaque components, and that means that anything that's solid needs to be insulated well to really make the building airtight, and to be sure that the equipment performance meets or exceeds the energy efficiency regulations. Next slide, please. The tiered energy code, next slide, is brought in. It's new in the 2020 edition. And I showed a slide earlier about this, but the new part's been introduced. And this is about tiered performance. So in Alberta, right now, the performance in Alberta is at Tier 1. But in Saskatchewan, it's at Tier 2. And in British Columbia, it's at Tier 3. Next slide, please. So the targeted, the targets for compliance 1 to 4 are specified in the 10.1.2.1 and will be determined by modeling the proposed and reference buildings. So again, the reference building is the building that is the lowest possible denominator, and in order to be at Tier 1, you're still building at the lowest common denominator. At Tier 2, you're building at 25% better, etc. Next slide, please. So 9.36 is for small buildings. All of the stuff we talked about earlier is for Part 3 buildings or for commercial buildings or for bigger buildings typically bigger than 6,000 square feet. 9.36, it can be commercial buildings, it can be small multifamily buildings, but it's generally smaller buildings and most often residential. Next slide, please. So the differences in the relationship with 9.36 is that it is tied completely, all of the same rules apply, except the lighting requirements are not the same. There are no lighting requirements for 9.36. Next slide, please. As stated earlier, these are the codes. These are the tiers that 2020 has included. Some of the things to consider for buildings as we go forward in smaller buildings, that more efficient windows and doors and skylights are going to be required. Minimum performance for the heating and cooling equipment is required. Professional calculation for the heating and cooling for residential buildings, which has never been required before, will be required. An air tightness minimum of 2.5 ACH at 50 pascals. New set points for indoor air temperature for energy modeling, and new hot water usage numbers for energy modeling, and the tiered energy code. So every province can elect to be at whichever tier they want at this point. And then as time goes on, the next building code, it'll be the next tier, the next building code, it'll be the next tier. Next slide, please. So what this energy code is doing is helping builders, developers, owners to think about buildings differently than they have in the past. Next slide, please. So new tools will be required for everyone, every type of building, small to big to large, in order to implement this program. Next slide, please. And in order to do that, in order to do this planning, regardless of the path that's taken, all members of the team will have to be consulted beforehand in order to make sure that the goals are met, and that the ways of meeting the energy code are doable within the skill set and what's available in the location, or what's viable in the location that the building is being built. Next slide, please. So this is an image that's just showing a building as a system. And that is what the energy code is attempting to do. So from the very first slides that we looked at, where building is a system, that is what the NECB's aim is. Just thinking about buildings as a system. And better built and energy efficient buildings are not a sum of many parts. And a checklist, sometimes for the prescriptive path, just doing the checklist seems like it's just a bunch of disparate parts, but it's been arranged and it's been developed so that that isn't even possible. One thing affects another. So it's an integrated entity, and it depends on all of its components and systems to work together. Next slide, please. Why are we doing this at all? And the idea here is that we make buildings more efficient, that the buildings it's possible to have the buildings become net zero. And what is the benefit for that? The initial design costs in the construction, which are they're visible and they seem like they're onerous, will be saved over the lifetime of the building. And buildings that are built better will last longer. The costs for maintenance and the cost for supplying energy for the building over time will be paid for, and the building essentially, if it's built to net zero standards, will be functioning and running for free eventually. Next slide, please. So this is a great image, it's easy to understand. Passive house as a building method that would be about tier 5, and so that is about 90% better than code at this time. But by doing a passive house and incorporating low embodied carbon, which we haven't talked about yet, but is coming, something that we should be thinking about, make sure that we can electrify everything and use clean energy so that we have a zero carbon building. Next slide, please. And back to where we started in terms of thinking about buildings and their location and minimizing the inputs into the building and making sure that the building itself is comfortable on its own with that very few inputs. Next slide, please. So why are we doing this? Because in Canada, the third largest emitter of GHG emissions, with over 96% of building emissions are coming from space and water heating in Canada. And the major changes in the building sector are underway and have a potential to create hundreds of thousands of sustainable jobs. and improve energy affordability for Canadians and better equipped our communities to withstand the effects of climate change. Big change. It's a big change, big way of change in thinking. But by making these changes and doing them incrementally over time, and people are getting more used to the idea of incorporating these changes, building stock will not be the third largest emitter of GHG emissions in Canada. Next slide, please. By the way, they're bigger emitters than all of the gas vehicles in Canada. How can the NECB benefit the Indigenous communities and associations, communities, and infrastructure projects? So this is where we were headed for this presentation. Next slide, please. So in my mind, the sustainability is part of two-eyed seeing, and what that means is that that both cultures are meeting together, and the meeting together part is where the realization that you can't just impose things on the environment, just can't impose things on people and expect that to work out. That thinking about buildings as a whole and thinking about their place on the planet and thinking about their impact now, their impact in the future, is a way of an Indigenous way of thinking of anything. Next slide, please. The importance of thinking about buildings and their layout on the land and where they are is also an Indigenous way of thinking. Next slide, please. Low carbon materials and natural materials are something that we are not enforced and not really mentioned in the Energy Code now, but they are something that we will be considering and have to consider going forward, because building buildings better using a lot of high GHG materials or materials that have a huge embodied carbon or upfront carbon that use a lot of energy to be manufactured and are not recyclable and are harmful to the environment is not improving the building stock. In some cases, the buildings and using materials that are harmful to the environment now actually use more energy in the construction of the building than they'll ever save in their lifetime. And this also is an Indigenous way of thinking of using local and using natural materials. Next slide, please. So in the end, as this kind of code, as these codes are enforced and as they are required to be enforced, what will happen is that buildings across Canada, but most importantly for Indigenous communities, will be comfortable, healthy, resilient, a refuge, and built to last centuries and not a couple of years. Next slide. Thank you. Okay, so do we have questions? I'm sorry, I haven't been watching the chat.
No problem at all. Thank you so much, Kim. I thought that was incredibly interesting, but also very technical. So I just wanted to remind everyone that this webinar will be sent out to everyone that registered within 24 hours to your inbox. So you can take the time to go back and take a look at these slides that Kim has provided for us. I also wanted to say thank you to the Government of Canada for helping us put this webinar on. So we do have some questions. The first one's about climate zones, and they're asking, can you explain how the NECB 2020 addresses different climate zones and their impact on building energy efficiency?
Absolutely. And I don't know, Danielle, we can go back on some slides, kind of in the middle of the slide deck. So the Energy Code absolutely considers back farther into the technical part in the middle of the, yeah, keep going back a little farther. I think near,
Getting there, aren't we?
near the, we were talking about the building envelope. For every one of these parts of the NECB, the climate zone is considered. And there, we can stop here first.
Okay,
So
perfect.
because the climate zones are indicated and they're well known, and the requirements for each one of the zones has specific requirements, and then we can go back one, Danielle. I think that'll show us when we're farther back. Yeah, there we go. So for windows, for instance, this is just an example for windows. For each one of these zones, the windows need to perform better as the climate gets colder. So the degree days go up, the efficiency of the window goes up as well. So these are minimum requirements, and I can't say that often enough because the building code and the National Energy Code are good. They're world class, but they also are a minimum code. And what that means is that is the top level that most people, most developers, most builders build to, is the building code, and they may actually quote to you saying this is built to code standards. But that's where the ceiling is the minimum amount. When we can do better, and that's where the tiered code, and considering the tiered code and considering, well, if by 3035 the tiered code will bring the requirements up to tier 4, then why would I be building at minimum code right now? Why wouldn't I be building to tier 4 as a forward thinking person and forward thinking builder or developer so that my building is resilient and better performing in the climate that it's designed for? Does that help? Is that helpful?
I think it's very helpful, actually. It seems very technical, so I think that we're trying to get a grasp on it.
Yep.
Um, how does the building code impact the adoption of green walls and green roofs? Does it include anything on these?
So it doesn't exactly. So with green walls and green roofs, what would happen is that the impact of the materials would have to be calculated into the building envelope calculations. So something that happens with the building envelope calculations is that we consider the entire system in order to come up with an RSI or a U value or R value. And so just by stuffing some insulation, put an R20 bad into some studs, doesn't actually give you an R20 wall. It gives you an R16 wall because you're thinking about all of the components that are in that wall. So when we add a green wall, then we would look at the components of that wall and see how it impacts the entire wall. We also want to be thinking about anything that needs to be watered a lot, anything that is of a natural material, how we keep the needs of the plants away from the needs of making sure that the building is airtight and the building is also waterproof, resilient, and maintains its resiliency. Does that
Great.
help?
Yes, absolutely. Now we have a question from Priyanka, and Priyanka is actually an Indigenous energy efficiency champion, and they're wondering, how do you overcome energy storage limitations?
Really good question. And the question is wait, or the answer is wait. So, storage limitations are definitely a thing. As we know, more storage systems, simpler storage systems are being developed. And if we're looking at, say, generating electricity and through photovoltaics, traditionally, if you wanted to be off grid, be using a ton of car batteries, which is not the most energy efficient way of, or energy um, it's not the best way to do things. You're using car batteries, you're using toxic fluids, you're having to top them up all the time. They're requiring maintenance. And in the ideal world, we will we'll have batteries that can take care of any excess energy that we're using at any time, any one time. But one thing to think about is that when your energy systems are right sized, you can be using a lot of the energy actively in your building while it's being generated. And that's an important aspect. And if you're in a place that is not quite as sunny as where I live, might be thinking about different ways of using renewable energies. And sometimes that might be geothermal, or sometimes I don't like to rely on geothermal because it's an expensive and very complicated way of heating things. But sometimes it does make sense. Sometimes wind makes sense. There are different ways of looking at it. Ideally, you have a building that just doesn't require a lot of inputs, and it doesn't matter so much that you don't have storage, that the building itself is operating well without the inputs. Next.
That actually kind of brings me to this next question here, which is how should professionals approach the integration of renewable energy technologies in compliance with the new building codes?
I'm going to bring up something that wasn't mentioned specifically in the presentation, but an integrated design process is really important. In order to manage getting these kinds of buildings on track, we really need to be sure that we do the work beforehand and that we're integrating the services of all of the people who might be involved, and optimizing the building and optimizing what's available and who can supply what and how that fits within the budget. All of those things need to be figured out long before the ground is opened up in order to do a building or create a building. It's not that uncommon a practice in Part 3 buildings, uncommon in Part 9 buildings, but so needed. So needed because without an integrated design process, this is where buildings become way too expensive. They go way over budget because all of these aspects haven't been thought out beforehand. And there will be not just trade-offs in order to meet the energy code, but trade-offs with the budget and trade-offs with the way that buildings are built, or a particular building is built in order to maintain the budget, but keeping the goals in mind. So if the goal is to use PVs, but you're limited in a budget for the PVs, whether that's because of funding or whether that's because of roof space or whatever it is, then but you want to be net zero, then that's the starting point. You net zero, you're building towards what you can provide for the building.
Very interesting. Now, Priyanka has a bit of a follow-up question to the question she asked earlier, and she's saying, so we can actually manage energy rather than storing it?
Yeah. Well, yes. So you can. It depends on how into it you are. So in the past, still back when we thought that oil was going to run out, there are a lot of people who wanted to be sustainable and were off grid and managed to be off grid with the really ancient photovoltaics and really ancient those kinds of systems. But what they would do would be because they wouldn't even necessarily have battery backup, is to manage how they work through the day. Use your dishwasher, or you don't use your wash machine when you don't have any energy no energy being supplied. Very minimal amount of lighting at night, and you're just really depending on the building itself to do the performance. That is completely possible, but it is a lifestyle thing as well. If we want to just pretend that energy is unlimited, then we do need some sort of storage. And we can calculate how much energy is needed. It's easy to do with energy modeling software, and there's a lot of software out there. We depend on a couple of them, HOT 2000, especially for 9.36, for doing optimization to figure out how much energy is required for every building, and being sure that any energy systems that are added to the building will meet or exceed the amount of energy that's required by the building itself. But when you have a grid-tied system, so that means that your PVs are feeding into the grid when you're not using it. Still, when you are making energy, when the energy is being made by the photovoltaics on the site, and you're using energy at the same time, you're using that energy that you're providing on site. That is happening in real time. Then whatever you don't use goes back to the grid. And when you are at a deficit, then you are using energy from the grid. So we use the grid as a storage system, but for off-grid purposes, it's far more complicated.
It's very interesting. Um, Now, how do you see these new building codes contributing to Canada's net zero and carbon reduction goals? Is there an end goal here? Like we're doing this to reach net zero. How does this contribute to that?
So in the presentation, we can go back towards the end if you want, Danielle. Mentioned that buildings themselves contribute a significant amount of greenhouse gas to the environment in Canada, especially. We really rely on I think farther back, Daniel, or closer to the end. We really rely on fossil fuels a lot to heat and cool our homes. And much of the building stock that's existing was never built with energy efficiency in mind. It was built with, we have a lot of free gas and a lot of really cheap gas and oil, and we can just keep throwing heat at this, and that will be the way that we will survive in the cold. And the same goes for cooling systems. But I think a couple more slides, Danielle. The Oh yeah, quite a bit farther. The way that these codes will help is that by the time we are 60% efficient than buildings are today, and the new building stock is showing that efficiency, it will make such a difference in terms of overall operational costs as time goes on. I think it's the next slide. The oh yeah, I think the next slide. And oh, I guess next slide. Next slide. Yes, there it is right there. That was the one before. Oh, the one before, two before this one. That one. So 96% of buildings' emissions come from space and water heating, the GHG, in Canada. So that's more than all of the cars in Canada running all the time. That's more energy, more GHG gases. So you can make everything electric, all electric vehicles, and buildings will be the total worst offender in terms of greenhouse gas emissions. The real benefit to all of this is that not only will we reduce the greenhouse gas emissions by making buildings more efficient, the buildings end up being more comfortable, nicer to be in, quieter, and healthier inside. The VOCs are taken care of by good ventilation. So VOCs are any of the things that are off-gassing in your house. We can deal with smoke and still have fresh air with proper ventilation and proper filters. And we can be sure that we are our energy costs are lower and lower. So one big deal about electrification is electricity is not cheap. We know that. So when we're thinking about electrification and we're thinking about efficient electrical equipment, we still need to reduce the requirements for heating and cooling for the buildings in order to do that, to make it viable. So they have to go hand in hand, and this is still whole building thinking in order for that to be accomplished. Did that answer the question? I know I got a little bit carried away.
I think it does. I think that there's a lot of cost savings as well if they do this properly from the beginning. It sounds like they'll save a ton
In
on
the future.
So
the lines go like this. The costs are very high at the beginning, but the operational costs are low to start with. And as time goes on, you're paying that off, and your operational costs are still low. And then when we hit the crossover, it's free. All of your carbon, all of your energy costs are free at that point because you paid everything off. So you don't have the monthly, if it's a home and you're tied to a gas line, for instance, you have to pay for that gas line every month, whether you're using it or not. You have to pay for your electrical systems, whether you're using it or not. These are facts, but when we're making buildings that are net zero over time, that won't be a thing. That's just not going to be a thing. And if we're able to store on site, energy on site, which is coming, that will mean total independence from these systems that we're very used to. You can imagine that electrical companies and oil and gas companies are not super happy about these possibilities.
It's very interesting though. Okay, I just want to sneak this last question in from Priyanka.
Yep.
She's been so good. And she's asking, can we retrofit existing buildings to meet these net zero standards? Is there a lot of challenges here? What are we doing?
That's a great question. I think that's a really good idea for a follow-up webinar. Been doing a lot of what they're called deep energy retrofits for existing buildings, and we have to do this. We can't build ourselves out of this mess with new buildings. Existing buildings need to be paid attention to. There's a lot of approaches to doing deep energy retrofits, and a lot of that's driven by budget. But the goals will still be to try and get a building to net zero or net zero ready. So that's a good suggestion for a new webinar.
Absolutely. I think that if you're on this call right now, you'll be hearing about our new deep energy retrofit webinar that will be coming up soon. So hopefully Kim will join us for that as well. That brings us to the end of the time. I just want to say thank you so much, Kim, for joining us. Like I said, this was technical, it was informative, but you guys will get this in your inbox within 24 hours. If you have any of the other questions that were missed in the chat or the questions, I'll send those along to Kim as well. So thank you so much for joining us. Any last words before we leave the webinar?
Thank you so much, everybody, and thank you for your interest in this topic. A bit dry, but it is important to understand how this will affect all of us in the future in terms of any buildings and the cost of buildings and the efficiency of buildings in the future.
Yeah, it's not really a choice, but it's more get out in front of it before it happens. So
Right. Yep.
Thank you, everyone, and everyone have a lovely day. Thank you so much. Bye-bye.